Okay, I'm going to be doing an example from section 11.10 and 11.11, which is basically using Taylor Polynomials to approximate a function and also find the error that you have when you do that. So the function I've chosen to demonstrate is sine of x, and instead of looking around 0 like we've done so often, I'll do a different example where we center the polynomial around the value a equals pi. So I've kind of done half the work here already to set us up. I've started with the function sine and taken its derivatives right here in this table, and I've been plugging in pi, and you get a pattern that alternates between 0, -1, 0, +1, and so the terms would look like this with zeros in between each of those. So you basically have x minus pi to the first power, third power, fifth power over 1 factorial, 3 factorial, 5 factorial, and so on, and the signs just alternate between negative and positive. And so if I was to write the summation form of that, it would look like this. And one thing you might notice is if you compare this formula to the formula in the book, in the red box that's for sine of x centered around 0 instead of pi, these are just they're exactly the same except that the negative ones are switched. They're on opposite terms. And that just came because, as you notice, when you plug in pi, the cosine of 0 is 1, but the cosine of pi is -1. So it's switched the values of the negatives for all those terms. So, now that I've got that part taken care of, here's just a simple graph of it. This is sine of x, and we're going to be looking at pi, and we're going to ask, I'm going to, in this video, cover two different questions that are two different sections of your homework. One of the sections is, let's see, like numbers 25 and 26, and then the other type of question is examples from questions 28 and 29. So if those are the problems you're working on, these will help you do those problems. So the first question is, if you choose a specific x value, in this case pi plus 0.2, how many terms of this polynomial are we going to need so that we can guarantee our error would be less than 0.001? And then the second question I will answer is, if we use a certain amount of terms, in this case I just picked 2 terms, what interval of x, so what interval of x around the value of pi, will also ensure that for any of those x values the error is less than 0.001. So let's get started. First we'll do the question number 1. How many terms do we need so that our error is less than or equal to 0.001? For that I'm going to be using the remainder formula. Which is this formula from the book, and there's a couple things that we need to do with this to answer this question. First of all, we need to know what our x value is, and our x value is pi plus 0.2, so I could plug that in already. And if I take pi plus 0.2 for x and then minus pi, notice that that's just going to be 0.2, so I'll just throw that in there. And it's going to be to the n plus 1 power, all divided by n plus 1 factorial. And our job here is to find an n so that this value will be less than or equal to 0.001. We also need to deal with this m value. Now if you recall, the way we find the m value is m is a number that's always greater than or equal to the n plus 1th derivative of x for a certain width or interval. And this interval for us is going to be x minus pi plus 0.2. Wait, I said that wrong. Okay, so the interval for us will be the distance from x and pi needs to be less than or equal to 0.2. Okay, now how did I... So since we're looking at the value pi plus 0.2 and I need to decide how far away that is from pi, and the answer would be 0.2. So that's the distance d that goes right here. Okay, so to find the n plus 1th derivative of f, notice that our f back here was sine, and all the derivatives are either sines or cosines. So one thing I could do is decide what's the largest positive or negative value that's either sine or cosine could be when I'm around pi. And we could look at values around there and maybe choose a number like a half or something. But what's a common practice doing these remainders when you're dealing with sine and cosine is just to say, well, no matter how many derivatives I take, the function never goes higher than 1 and it's never smaller than negative 1. So a perfectly good choice for an m value would just be 1. So we're going to plug in 1 for our m value right here. Okay, and now I just need to figure out what n value do I need to plug in to make this less than or equal to 0.001. Well, if we try a couple n values, such as 1, then we're going to get, I'll grab my calculator here, 0.02, which is not less than or equal to 0.001, so we'll keep going. For n equals 2, we would get 0.0013, with the 3's repeating. And also that's still just a little bit too big for 0.001, so I'd have to go to one more value, n equals 3. And when I do so, then this expression is equal to 0.00006 repeating, which is less than or equal to 0.001. So to answer this question, how many terms do I need? This n value of 3 is telling me what exponent on x I would have to go to. So by the time that I have x to the 3rd power, this would be where n equals 3, because notice this is n equals 0, 1, 2, 3. Okay. So I would have to go to these first two terms with where n equals 3, because that's the power, to get an error smaller than 0.001. Okay, now I'll answer the second question, which is, for using two terms, what interval of x will ensure that that error is less than 0.001? So for those first two terms, I would like to know how far around pi could I move and still make sure that the error I have between sine and my approximating function is still smaller than this value. And again, I can use the same error formula, and I can say, well, for two terms, my n value turns out to be 3 because of that exponent right there. So I'm looking at r sub 3 of x. And that needs to be less than or equal to our m value of 1 times absolute value, x minus pi, to the 4th power, because n is 3, all divided by 4 factorial. And I would like to solve for the x values that would make this less than or equal to 0.001. So I'm going to go ahead and solve this inequality. And if I multiply both sides by 4 factorial, then I just have the absolute value of x minus pi to the 4th power being less than or equal to 0.024. Then I can take the 4th root of both sides, and I'll have x minus pi, in absolute values still, is less than or equal to, okay, it turns out to be 0.39359. So now to solve this, I can have two equations. X minus pi can be less than or equal to 0.39359, or it will also be true if x minus pi is greater than or equal to negative 0.39359. And if I solve both of those equations, then I'm going to get an interval for x. X needs to be between Let me calculate that on my calculator. Okay, so solving this one, I have x less than or equal to 3.5351. And on the bottom, 2.748.